Alright, so let's go to whole numbers. We are going to look at properties of whole numbers. Alright, what are whole numbers? Well, numbers starting from 0 all the way to infinity, because we don't really know where numbers end. So we can't say it's from 0 to 1,000 or 0 to 1,000,000. They're never ending. So numbers starting from 0 to infinity. And the first property we're going to talk about is the commutative property. What does that mean? It means that the order of numbers can be changed without changing the result. All right. So, is the following commutative? Is addition commutative? Well, let's see. If I were to say 8 plus 6, that gives me 14, right? All right. Now, if I were to change the order of the numbers, will it change the result? Let's see. So, if I have 6 plus 8, well, that's also 14. So, is addition commutative? Yes. So, when I use these 3 dots, it means therefore. Okay, so is addition commutative? We've tested with 8 plus 6 and 6 plus 8, which both yield 14. Therefore, yes. If ever you want to say because, you just turn it upside down. Okay, but let's just stick to therefore. So yes, addition is commutative. Now let's use the very same numbers and go to subtraction. So if I say 8 minus 6, I get 2. Now what if I say 6 minus 8? Will I still get 2? Well, I have a small number and I'm subtracting a big number. So I'm going to get a negative number. We'll discuss negative numbers when we get to integers. But for now, just believe me when I say 6 minus 8 is negative 2. You can check on the calculator. So is subtraction commutative? No, it is not. Now let's go to multiplication. I'm still going to use the same numbers. So if I say 8 times 6, now I need to remember your multiplication tables. Okay, 8 times 6, that is 48. And if I go and say 6 times 8, will I still get 48? Yes, you will. You can check it out. Okay. So is multiplication commutative? Yes, it is. It definitely is. We can see a trend here. When it comes to addition and when it comes to multiplication, then the commutative property does apply. Now, when we get to division, what happens? I'm still using the same numbers. So 8 divided by 6. I can actually write it as 8 over 6. Okay, so the fraction line, it's actually like saying division. Okay, and I'm going to simplify it. 8 divided by 6. If I simplify it, I will get 4 over 3. No, not 3 over 4, but 4 over 3. Okay, this is me just simplifying it. And if you check on your calculator, it's going to give you 1,333. Until we say 3 recurs, so it's recurring, but let's just leave it in fraction form. Now, what happens if I say 6 divided by 8? 6 divided by 8, I can actually write it as 6 over 8. Now, that is different, right? If I simplify it, we're going to learn about simplification. Okay, if I simplify it, I'm simply going to get 3 over 4. 3 over 4 is like 0.75. It's 3 quarters. Okay. 4 over 3, like I said, it's like 1,333. So the 3 is recurring. 3 over 4 is like 0.75. Is division commutative? No. So what can we summarize? Addition and multiplication are commutative, but subtraction and division are not. Okay. Now let's start with this exercise. It says, are the following statements true or false? Having learned about the commutative property, now 2 plus 4, we know that is 6. And 4 plus 2, that is also 6. So is the statement correct? Is it true or is it false? It's definitely true. Now 19 minus 4, okay, that's 15. But 4 minus 19, it gives us a negative 15. So these two are not equal, all right? As we learned before, addition is commutative, but subtraction is not. So already, if I see a subtraction sign, I know it cannot be commutative. Now, I see multiplication on number 3. 8 times 20, okay? So that's basically 160. 20 times 8 is also 160. And now it says the two are not equal. So this is false because the two are equal. All right? And then now number 4, we have 10 divided by 5, which is equal to 2. And 2 divided by 1 is 2. Now we have 1 divided by 5. 1 divided by 5 is 1/5 is actually 0,2, and 0,2 divided by 10 is actually 0,02. So do you see that the two are not equal? And yes, the statement said the two are not equal. So this is true. All right, and then we are done with exercise 1.1. Now we're looking at the grouping property. All right, so we can say it's the associative property of whole numbers. Now, how do we group? All right, the way in which numbers are grouped does not affect the result. That's what it says for this associative property. And the way in which we group, we use brackets. All right, so as we start, we need to answer the following question. Is the following associative? When we do addition, is it associative? So I'm going to start with another example. Let's say we have 5 plus 7 plus 3. Okay, now if I group 5 and 7, so I'm just going to do that. I'm going to group 5 and 7 and I add 3. Then I'm going to group 7 and 3. And the question is addition associative? So if I say 5 plus 7, this gives me 12. 12 plus 3 is 15. Now, on the other end, maybe let me just leave it here because this is what you're doing as you're working out. If I say 7 plus 3, we always start with what's in the bracket. Remember, bottomers, brackets of, you start with the brackets, then you can go over to multiplication, division, and then finally addition and subtraction. BOMDAS or BODMAS, it doesn't matter. So let's start with the brackets. So 7 plus 3 gives me 10, right? And what is 5 plus 10? It is 15. So is addition associative? I'm going to write it at the bottom there. Yes, it is associative. What about subtraction? Still using 5 plus 7 plus 3. I'm going to then, no, let's actually use different numbers. Let's say we're going to use 16 minus 8 minus 5. All right, now let us group 16 and 8. And then later on, let us group the 8 and the 5. Okay. So, 16 minus 8, that gives us 8. And 8 minus 5, that gives us 3. Now, when we start with brackets, 8 minus 5, that is 3. All right. Now, 16 minus 3, that is 13. So, is subtraction associative? No, it is not. Now, let's go to multiplication. I'm going to use different numbers over here. Okay, or let's use different numbers. So here I have 5 times 2 times 9. All right, So if I say 5 times 2 times 9, what will happen if I leave 5 out and then I multiply 2 times 9? Okay, so 5 times 2, that is 10. 10 times 9 will give us 90. Okay, and then 2 times 9, that is actually 18. Okay, and 18 times 5, if you don't have your calculator, let's just do it the long way. I'm just going to do it up here. So I have 18 times 5. 8 times 5 is 40. I'm going to put 0 there. Carry the 4. 1 times 5 is 5. 5 plus 4 is 9. So 5 times 18 is actually 90. What does that tell us about multiplication? Multiplication is definitely associative. Okay, I'm not going to put in the exclamation mark lest someone thinks we're shouting at them. What about division? Okay, let's use the numbers here. Let's see if I say 20 divided by 5 divided by 5. Or maybe let me say divided by 4 and then divided by 5. So firstly, we're going to start with 20 divided by 4, and then we're going to divide by 5. And then secondly, we're going to have the 20 outside, and then we have 4 divided by 5. So 20 divided by 4 in the brackets, what do we have? We have 5. And what is 5 divided by 5? Well, that is 1. Then we have 4 divided by 5. 4 divided by 5 is actually, it's 0.8. I'm just thinking of a way of writing it. Okay, I'm just going to leave it as 4 over 5. But now what is 20 divided by 4 over 5? We are forced to go into a fraction lesson. So what do you do when you have 20 divided by a certain fraction? So I'm just going to work it out here. So 20 divided by 4 over 5. Okay, my pen was just malfunctioning. So 20 divided by 4 over 5. When you are dividing by a fraction, there's a law that you can use that now you can use multiplication. But when you multiply, you need to swap the numerator and the denominator. So I actually have 20 times 5 over 4. Okay? And whenever we multiply fractions, we multiply the numerators together. So 20 times 5 is 100. And 1 times 4 is 4. And what is 100 divided by 4? It is 25. So we can go ahead and write our answer. 20 divided by 4 over 5 is actually 25. So is division associative? No. Alright, so here we can see that another trend, again, just like with the previous property of being commutative, addition and multiplication are associative, but subtraction and division are not. And let's go over to our exercise. Exercise 1.2. It says, are the following statements true or false? So here we have 2 plus 3, which is 5, and 5 plus 4, that is 9. On this end, 3 plus 4 is 7, 2 plus 7 is 9. So is 9 equal to 9? Yes, it is. So this is true. In the second question, we have 14 minus 10. 14 minus 10 is 4. And 4 minus 4 is what? 0. Then we have 10 minus 4, the brackets, that is 6. 14 minus 6 is 8. So yes, 0 is not equal to 8. So that is true. Then we head over to multiplication. So it says 4 times 3, what is that? That is 12. Now what is 7 times 12? Okay, if you don't know, just work it out. Okay, 2 times 7 is 14, you carry 1 over. 1 times 7 is 7 plus 1 is 8. So this is 84. And on the other hand, 7 times 4 is 28. Now what is 28 times 3? Can work it out. I know you guys have calculators, but please try to work certain things out in your head without the use of calculators. But 8 times 3 is 24. We carry the 2 over. 2 times 3 is 6, plus 2 is 8. So 84 is equal to 84. So now here it's saying it's not equal. So therefore this is false. And lastly, we have 14 divided by 7 divided by 7. We start with brackets. 7 divided by 7 is 1. So 14 divided by 1, that is 14. Now, with the brackets this side, 14 divided by 7 is 2. 2 divided by 7 is just simply 2 over 7. Okay, these two are not equal. So therefore, this is false. Let's have a look at the distributive property. So what does it say? The distributive property says the result of multiplying a number by the sum of two or more numbers is the same as adding the results of multiplying the numbers separately. What do we mean by that? Okay, let's say we have a number. We don't know what it is, so we can assign a variable to it called x. We're still going to get there. So let not me writing down x deter you or make you think that maths is hard. We're still on that same flow. Maths is easy. We don't know what number it is, so we just put x. So if we say x, okay, the result of multiplying a number by the sum. So I'm going to multiply it by a sum. Let's say y plus z of two or more numbers. Okay, so the result of multiplying a number by the sum of two or more numbers is the same as adding, so it's the same, so it's equal to, the same as adding the results of multiplying the numbers separately. So it's the same as then multiplying the numbers separately. X times y plus x times z. This is what this rule is saying. But let me not use just variables. Let me use real numbers. So if I were to use, for example, 5 times 3 plus 4. Okay, so I know that 3 plus 4 is 7. 5 times 7 is 35. All right, will it be the same if I then take 5? Let me use a different colored pen. 5 times 3. Okay, so here I have 5 times 3. Or let me just use multiplication sign. 5 times 3 plus 5 times 4. So 5 times 3 is 15. And 5 times 4 is 20. 15 plus 20 is 35. So yeah, this is the distributive property. Okay, this is the first part of the distributive property. Now let's look at the other portion of the distributive property. It says the result of multiplying a number by the difference of two or more numbers is the same as the difference of the result of multiplying the numbers separately. So same thing. If we were to have x times y minus z, okay, it's basically the same as saying x times y minus x times z. All right, let's use different numbers this time. So maybe let me say 6 times 5 minus 4. Okay, and then we say 6 times, okay, 5 minus 4 is 1, right? 6 times 1, that is just 6. Now on the other end, I say 6, use a different colored pen. Okay, 6 times 5 minus 6 times 4. So 6 times 5 is 30. And 6 times 4 is 24. What is 30 minus 24? That is 6. All right. So yes, that is the distributive property. You are distributing, all right, this 5 among, in the first case, the 5, you are distributing it among 3 and 4. Or in this case, you're distributing the 6 among 5 and 4. All right, so this is the distributive property. What about division? Let's just talk about it while we're here. You've realized that division is not associative, division is not commutative. Well, not a surprise here. Division is not distributive. Okay, it is not associative, it is not commutative, nor is it distributive. All right. So the result of dividing a number by the sum or the difference of two or more numbers is not the same as the result of dividing the number separately. Okay, for example, we always need to check whatever theory that you have, you need to make sure that it checks out properly. So if we were to say 10 divided by 2 divided by 3, will it be equal to 10 divided by 2? Okay, and then we're also going to divide, plus, not divide, 10 divided by 3. Okay, well, let me rather do it like this. Yeah, I didn't face that question properly. Let's say 10 divided by 2 plus 3. Okay, is it going to be equal to 10 divided by 2 plus 10 divided by 3? Will the 2 be equal? Let's see. 2 plus 3 is 5, right? So 10 divided by 5, that will be 2. Now on the other hand, let me just separate the two. 10 divided by 2 is 5. 10 divided by 3 on the other hand, it's like 3 comma something. But yeah, so 5 plus 3 comma something, that's just going to be 8 comma something. So the two are definitely not equal. So division is not distributive. Okay, and let's now look at an exercise. So are the following statements true or false? We're going to look at the distributive property. So 2 times 3 plus 5 is 8. So 2 times 8 is 16. Now if we look on the other end, 2 times 3, that is 6. 2 times 5, that is 10. And 6 plus 10, that is 16. So yes, these two, what is written there, that is true. And then number 2, we start with the brackets. So we have 6 times 8 minus 5 is 3. All right. So 6 times 3, that is 18. Then we have 6 times 8. 6 times 8 is 48. 6 times 5 is 30. So 48 minus 30, that is 18. So the two are actually equal. So this should be true. And we are expecting the distributive property to work here. Remember, it doesn't work where we have division. And here we are dealing with division. So we are expecting the two not to be equal. So now we have 16 divided by 4 divided by 2. We're going to start with brackets. 4 divided by 2, that is just 2. So now we have 16 divided by 2, and that is 8. Now we have 14 divided by 4. 16 divided by 4, which is 4. And we have 16 divided by 2, which is 8. And what is 4 divided by 8? We can rewrite it as a fraction. And if we simplify it, that is simply a half. So 8 and a half are not equal. So this statement really is true. Ooh, I see I did a boo-boo in the previous question. It says that the two are not equal, so that is false. Ah, yes, this is false. All right, and that is it for the distributive property.